Okay, so forces of motion, part 2, and we are starting with acceleration. I hope. Okay. So, acceleration, what is it? It's the rate of change in an object's speed. So we're taking the speed, and rate of change always means divided by time. If you're looking for a book, you know where to find it. Okay, acceleration, we can either have increasing acceleration, meaning the object is speeding up, or we can have decreasing acceleration, meaning it is slowing down. If I want to have uniform acceleration, I have to have the speed changes at a constant rate. That will give me uniform acceleration. If we just had uniform motion, that means I have a constant speed and a constant direction. So now uniform acceleration, the speed changes at a constant rate. So when that happens, again, if we say at 1 second, my speed was 3 meters per second. At 2 seconds, it was 6 meters per second. And at 3 seconds, it was 9 meters per second. And that tells you that every second, your speed is increasing by 3 meters per second. Because there's added to 3, added another 3. Okay, so top part here it says sketch the shape for an object that is slowing down at a constant rate. Slowing down. So if it's slowing down at a constant rate, we should have something like that. Okay? Or that means this guy, oh, sorry, that's not slowing down. No, that doesn't work. Here, that. Okay, that is slowing down at a constant rate. So here we do that little tangent line, and it is very steep. Here, this is very flat. So that means its speed is decreasing. So here, if I have a speed time graph, I want to show the speed is decreasing. So that would work. I'm getting lower and lower and lower speed.
Is that supposed to be a straight line?
Yes, that is definitely a straight line. Well, maybe. Okay? Now, let's look at another possibility. If I want to have slowing down at a constant rate, perhaps I could do this as well. So again, this would say it is very fast. Here, the speed is very slow, but it looks different because the object is going towards home. The speed is still slowing down at a constant rate. When I do my graph for speed time, it will still look like this. Because when we're looking at speed time sketches here, it's not going to tell us anything about whether the object is going away from home or towards home. It only indicates the speed. So this here, the speed is decreasing as you go down the axis. So it is slowing down. When we do the slope of a speed time graph, the slope is going to equal to your acceleration, okay, for a speed time graph. We should have a second slide in there. Okay. There. Object that is slowing down at a constant rate. Didn't we just do that one?
Yeah, it's one back.
Slowing down at a constant rate. Oh, speeding up at a constant rate. Okay, so we want to speed up at a constant rate. So we can do two different ones. Can be going away from home or towards home. Again, I want to speed up, so I can look like that. That would be increasing its speed. So down at the bottom here, it is fairly flat, so speed is small. Up at the top here, it is steep, so speed is fast. So this one would be speeding up. At a constant rate, that means my speed time sketch is going to be a straight line segment. It is going to be speeding up at a constant rate. And so, let's look at the other possibility. If I want to go towards home, I could have something like that. So it starts off fairly flat, low speed, ends up steep, so a high speed. This object is going towards home, and it is speeding up, and my speed time sketch will still look the same. It's going to be a straight line segment. And again, the slope of that speed time graph is going to equal acceleration. Okay, now we can get through that. So, acceleration is the rate of change in speed. The lowercase a is equal to your acceleration. The v is equal to your velocity, or like I said, this we're going to now consider speed. The only way that we can say velocity and speed are equal is if we're going in a straight line segment. So once we learn the difference between velocity and speed, then we'll do some more problems with velocity in there. So speed, acceleration is speed over time. So remember that little triangle means change in. The change in speed over the change in time. Okay, when we have acceleration, usually you'll see the units as meters per second squared. Sometimes you still see kilometers per hour per second, but meters per second squared is the standard way to write it. Change given two velocities or speeds. Change in speed is your final speed minus the initial speed. Positive value means you're going to have the acceleration is increasing, and a negative value, when you subtract those, means the acceleration is going to be decreasing, and we have deceleration. Uniform acceleration is the same change in the speed occurs in equal intervals of time. And again, that was the same thing as saying, oh, each second my speed increased by 3 meters per second. Average is the average rate of change in the speed of an object. Okay, so let's look at this. when we do the questions, we're going to do them the same way as we did part one. We have to write down what we know, what we're looking for. We have to write down the equation. We have to fill it in and write down the answer, do sig figs, write down units. So we need to have our equation sheet out so we know which equation to pick. Yes, from our formulas. So a runner started running at 4 seconds. So initially the time was 4 seconds, T1, and T2, he finished at 14 seconds. Okay. Initially it started at 4 seconds, he finished at 14. Well, I'm going to have to find out what my change in time is. Change in time is your T2 minus T1. So T2 is 14, T1 is 4, so my change in time is 10 seconds. Okay, let's keep going. The speed was from, the first value is my initial speed, so 10 meters per second, and the final speed is 60 meters per second.
So we go V1, V2 minus 10.
So I want to find out my change in speed. Change in anything is always the final minus the initial. And we end up with 60 minus 10, or 50 meters per second. Then it says, what was the runner's acceleration? So we're looking for the acceleration. So when we go through this, we find on our formula sheet, acceleration is equal to the change in speed over the change in time. Okay, so change in speed, 50 meters per second. Change in time, 10 seconds. So we have 50 divided by 10, or 5 meters per second squared. The 2 seconds gives you your second squared. That is the correct number of sig figs, so all is good. Questions with that? Okay. Okay. So our next example. A car was clocked driving at 5 meters per second. 10 seconds later, it was driving at 4 meters per second. What is the acceleration? So, the initial speed is 5 meters per second. 10 seconds later, it was driving at 4. So my final speed is 4 meters per second. Okay, so I'm going to have to find out my change in speed, which is V2 minus V1, or 4 minus 5, and I get a negative 1 meters per second. Meaning this guy is slowing down. Now, it says 10 seconds later, so the change in time is just 10 seconds. It didn't give you a starting time, ending time, it just gave you the time for the whole thing. So it's 10 seconds. And I am just looking for acceleration. So I know acceleration is change in speed over change in time. So I'm going to have 0.1 or negative 1 meters per second over 10 seconds.
I got negative 0.1.
Okay, so what should we get? Everyone give that a try. -1 divided by 10. Yeah, with 0, negative 0.1 meters per second squared. So what does that tell us? It tells us that every second your speed is decreasing by 0.1 meters per second. Okay, so that's what we mean by negative 0.1 meters per second squared. It's telling you that every second your speed is decreasing by 0.1 meters per second. Every second. So, after 1 second, what would this guy's speed be? He started at 5 meters per second. 1 second passed, what would his speed be? So at 0, he has 5 meters per second. 1 second later, what's his speed?
No, 5.
4.9. He decreased his speed by 0.1 meters per second. Okay? 2 seconds later, what is his speed? 4.8. 3, 4, 5, 6, 7, 8, 9, 10. Okay, so at 3 seconds, 4.7. 4 seconds, 4.6. 4.5. 4.4. 4.3. 4.2. 4.1. And 4 seconds. 10 seconds later, it is 4 meters per second. And so it tells you it's decreasing its speed by that amount. Okay, so now we have questions in our booklet. Okay, so we're looking at question 1 on your motion problems. And we want to, just like we always have done, we write down what we know and what we're looking for. And it says, a rabbit started running at 8 seconds and finished at 18 seconds. So I know my initial time is 8 seconds, and I know my final time is 18 seconds. Okay? So what do I know about my change in time? It's always T2 minus T1, or 18 minus 8, or 10 seconds. So that's that much I know. The distance ran. Oh, well, distance. So my D1 is 15 meters, and my D2 is 75 meters. Okay. What is the rabbit's acceleration? We look at this and say, wow, that's good, but acceleration is equal to change in speed over change in time. Okay? I don't have change in speed yet. But I do have an equation where I can find out my change in speed. Change in speed is equal to change in distance over the change in time. Okay, well, I don't really quite have change in distance yet, but I can find that out pretty quick. Change in distance is equal to D2 minus D1, or 75 minus 15, or 60 meters. Okay, so we have to start with this equation and then go to the acceleration equation. So change in speed is equal to 60 meters over 10 seconds. So my change in speed is 6 meters per second. Okay, well now I have enough information for equation 2. Acceleration is equal to change in speed, 6 meters per second, over change in time, 10 seconds. So I have 0.6 meters per second squared is your acceleration. So every second you are increasing your speed by 0.6 meters per second.